stage, I'm your mother effing MC, P to the E, T, R, D, P, AOL. Hey, you guys remember AOL? Hey, I'm Ramir. I'm here to tell you we're about to motherfucking break your brain like hello world. Got the blockchain spinning. Everyone's here, hope you're enjoying dinner. Last line. Is the future here? I don't know, but it's about to start. Cause it's near. Alright. Welcome guys. I just made that up, so that's why it's that. But my name's Peter. I work at Near. Usually these events are really boring, so I wanted to kind of, kick it up a little bit. So I think you guys read the tag, so I'm not going to do a long intro. This is Zaki from Cosmos, total badass. This is Illia from Near, also total badass. And we're going to hear them talking about some cool stuff. Oh, thanks, I can take my phone. So just so you know the format, if you have some burning questions, hold them, because about halfway in, I'm going to pass it to the audience. Somebody's got a little square in the audience. Someone? Yeah, let me show you. No. So this looks weird, but this is so we can record this for later, the audience questions. So if you want a question, if you have a question you want to ask, someone will pass you the square, you can talk into the square and we'll record it. So just a preview. So you can forget that, but if someone gives you a weird square, that's why. All right, let's get started. Ilya, do you want to ask the first question, or do you want me to ask a C question? I'll let you.
Go ahead.
Okay, so I'm going to start with one of the most technical questions burning on everyone's mind, which is, if you were an animal, which animal would you be?
I think I've always had a natural affinity for hedgehogs, so I think that is my spirit animal.
Ellie, what about you? Dragon.
Okay. Oh yeah, that's all I've got. So I'm going to pass it to these guys. They're going to have a quick discussion about whatever they want to talk about. I think it'll be really cool.
Hey everyone. Thanks for coming on a very busy night, I'm sure, in San Francisco Blockchain Week. So the topic of this kind of discussion is app chains versus dApps. And this is kind of the discussion we've been having for a bit now, which spun off from like the idea of what's better, Cosmos or Near?
Or is Near just part of Cosmos?
Or Near part of Cosmos, or Cosmos is part of Near, yeah. Or Cosmos is Near, we can figure this out. But I mean, the kind of where this is coming from is this idea that if I'm a developer, right, want to build some application, which platform should I choose, right? Really, this is kind of a big question that a lot of people are asking. And let's just start, what's a good arguments for choosing an app chain or like a Cosmos chain, Cosmos zone?
Okay. So I guess in my mind, the first question to ask is in my mind, what is Cosmos? How do you know, what is a Cosmos chain? So the core idea of Cosmos is, building Tendermint was a means to an end. Building the Cosmos SDK was a means to an end. The end is this thing that we're demoing either tomorrow or the day after at the DeFi hackathon called IBC, Inter-Blockchain Communication. And inter-blockchain communication is an idea that goes back really to the 1990s, where the first were Mark Miller and all the founders of what is now Agoric were working under Xerox and a variety of different other entities, startup companies, et cetera, on this idea of smart contracts as asynchronous communication between sovereign systems. And I found this work on the internet. I didn't know Mark or any of the Agoric people at the time. But it came out of my frustration with the whole sharding conversation. Basically, in 2016, I'm gonna we have time. I'm just gonna do the whole story. I feel like I have to frame the whole story. It has to make sense why Cosmos is the way it is. So we'll do the whole story. So 2016, I'm sitting across a desk every day. I'm doing a enterprise blockchain startup. Sitting across a desk from Dominic Williams, who's working on Definity. It was kind of a side project for him at the time. And every day at lunch, we would argue about sharding. Then I would go on the internet and argue with Vitalik and Vlad about sharding. I talked to Jay about Tendermint. And I got real frustrated by what Alex has, I think, actually branded really nicely, the adaptive corruption problem, but it was a problem that like really frustrated me in 2016. So I was like real sad about it. And I'm like, because basically what happens with the adaptive corruption problem is if you build a sharded system, the whole system, if one shard gets taken over by an evil set of validators and they do an invalid state transition, and it gets recorded into the rest of the system, there's not really any completely sane way to like go and like fix the system. You kind of have to like stop the entire universe and fix it again. So I found this work on the internet at this like super 90s website called erights.org. It's still up. It's the most 90s website ever. It's full of brilliant ideas. And I'm like, I don't know how to adapt these ideas to blockchains, but I think they're really cool. And they basically have a framework where if evil validators take over, or you know, if you end up interacting with an evil computer in their system, you can actually figure out what that evil computer did and like manage the damage. So I got really excited about this. I started talking to Jay and Ethan about it. That idea turned into Cosmos. We realized that in order to build this idea, you needed consensus and a machine for building blockchains. So we spent, you know, basically the last 2-ish years building that. And then once we built that, we could actually implement IBC. Along the way, all of the people whose ideas this originally was, started a company called Agoric, and we have the privilege of working with the original creators of the idea to deliver IBC, and IBC now is the sort of formative thing of Cosmos. But when you say an app chain, you see, I think we have like 2 really good canonical examples of them. One is a chain, actually we have 3. I would say we have the Binance chain, the Binance DEX chain. Probably like the most heavily used, highly transacted upon, value carrying Cosmos network, Cosmos SDK Tendermint network in the world. We have the Terra blockchain, which is probably the blockchain that is most used for non-speculative applications in the world. It's used for payments. And you have to ask the question, would either of those chains, and Libra is kind of also like, it's like alt Cosmos, like take all of my all of the ideas I've been working on 5 years to like get out the door, and they like are like, we'll hire 40 Facebook engineers to like remake them. Cool, thank you. It was free. So like those are the kinds of things that I think of as when we talk about app chains. And I think the best argument for like why app chains will always exist is there's fundamental social reasons why a company like an organization like Binance, an organization like Terra would want total control of the environment that they're operating in. They want a blockchain, but they want their community, their aligned self-interest to fully control the system. And I think that is probably why I think IBC and app chains are a big part of the future.
Cool, yeah, that's a good story. I mean, one thing that's like the way I like to portray the kind of difference between app chains versus like building an app on, you know, Ethereum or some other smart contract platform is that spinning up your chain is actually a lot of work. And that's actually the reason why it makes sense for these companies is because they have resources to do this work. And in case of Binance, like they are the most of the work is integrating with themselves. So
yeah, and like strategic integration. In the same way with Terra, most of the work is go to market, and like the blockchain is just like a real-time gross settlement system for them.
Yeah. So yeah, if I'm a developer, right, and I'm trying to spin up a product, the amount of work you need to do to actually get from I have the standard like Cosmos SDK to this Cosmos SDK is accepted everywhere. It's in everybody's wallet and it's on exchanges and people can use it. That's a lot of work, right?
Yeah, but maybe IBC makes that easier.
Let's talk about it. So the kind of flip side of this, right? If you just deploy an app on Ethereum, you kind of get like a lot of it for free in a way, because you're working in the same common environment. So the kind of the idea I use is pretty much building an app chain is like building up your own data center or building up your own server rack, right? It's a lot of work. You need, buy the hardware, set it up, configure, hook it all together. You get a lot of like value out of it because you have full control. You can install some better networking equipment, etc. Or you can go and like launch an app on the cloud and kind of get maybe less performance, a little bit higher price, but you can do it today, right now, from your computer. So that's kind of the way I like to look at it. And obviously, like there's a reason why like Google and Facebook would not use Amazon to to run all of their computation there, because they're like way too big, and at some scale it actually makes sense to set up your own infrastructure and actually do all this work. But the good example is like Netflix, which kind of grown up with Amazon, and even though probably now it would totally make sense for them to have their own infrastructure, it is embedded into ecosystem so much that it's actually will be really hard to integrate. So I think like we had the discussion before that you said like for some applications like Maker, it would actually make sense to move out of Ethereum and spin their own chain, because they're actually not leveraging Ethereum as much as they could have, or like as
well, I mean, like,
as they're paying for.
Yeah, well, they're paying a lot to use Ethereum. They're not getting additional security from Ethereum. They are all, well, they and things that are functionally competitors to them have become like essentially, Leland and Haseeb had a great paper about this, I think that came out yesterday or this morning. I saw it on Twitter this morning, about how like effectively all of these applications have become de facto the governance layer of Ethereum. So, okay, I want to like, let's like try and systematize this conversation, because on the whole, I think we probably agree with each other. I think Near is a great project. I think building sharded blockchains is awesome, and I'm super excited that it works. I just, I think we're working towards like two pieces, or there are many pieces that we have to get right to build a global crypto economy. I think Near is going to be super happy that IBC exists, so they can connect to the Binance DEX and get liquidity and assets from there to interact with and like bootstrap liquidity on Near. I think that'll be cool. And like basically what IBC should ideally allow for the entire fast blockchain ecosystem. Near is a fast blockchain. Cosmos chains are a fast blockchain. Polkadot is a fast blockchain. E2.0 is a fast blockchain. All of these fast blockchains, you'll be able to instantly bootstrap liquidity in the same way that you can instantly bootstrap liquidity on Ethereum if you're ERC20 via IBC. Because Near can implement IBC, they can connect to the Binance DEX's implementation of IBC or the Cosmos Hub's implementation of IBC, and immediately get access to all the exchanges that have already integrated on the Cosmos Hub, etc. So when we think about like what the Cosmos vision is really enabling, it is enabling it. The core goal is to get as many of the benefits of being on one big integrated chain, sort of available to this entire ecosystem of fast blockchains.
So I mean, let's actually dig deeper how IBC actually enables it, right? Because from the perspective of, let's say I'm an exchange, right, that would be integrating, and let's say, I mean, Binance DEX is one example, right?
Yeah, I think let's talk about the Binance DEX and like imagine this world, because it's like concrete and like I think most of the people in this room have like this have a mental model of like what Near live will look like. Like when Near's live, there'll be DeFi applications, there'll be gaming applications, digital assets of all kinds will be issued on this chain. It'll be this rich ecosystem. And over time, though, Near probably will get many exchanges that integrate with it, but you also will have this Binance DEX ecosystem. The Binance DEX ecosystem will have many appealing things. It'll have on-ramps and off-ramps in many jurisdictions. You'll have like liquidity on it. So all of these things will be really attractive features of the Binance DEX. And so you're sitting, you're a video game developer. You've issued a bunch of assets on Near, and you want people to be able to sell them. there'll definitely be various decentralized, centralized NFT exchanges that connect directly to Near, but you see this like possibly giant pool of liquidity to the Binance DEX. So there's an IBC connection between the Binance DEX and Near. You freeze your NFT on Near. You generate an IBC packet. It gets sent to the Binance DEX. Your NFT gets created on the Binance DEX. People can trade it. They can collateralize loans with it. They can do all kinds of crazy shit. They can go 100x leverage on your CryptoKitty. And that's the world that I've been working towards.
But at the same time, IBC right now connects to Tendermint chains, right? So you still need a peg zone, which will pretty much...
For Near, all we need is a light client. Like that's canonically all IBC needs. It's just nobody else has written down how a light client works for any of their consensus protocols.
Because for fast chains, light clients are really hard.
I mean, we did it. Cello's doing it. I'm sure there's a way to make Near work.
I think that the joke was, I think James made it, that everything that starts with C has a light client. So Coda, Cello, Cosmos.
Sure. I mean, yeah, I don't know. We were talking a little bit about how Near's consensus works, and I haven't figured out exactly how a light client's going to work, but I suspect there's a way.
Quick interjection. This is a moderator question, which is how light of a light client, right? This gets thrown around a lot, the idea that you need a light client. But I mean, I could just make an argument, oh, this node I'm running is a light client, right? So can you define like how light of the client it would have to be?
Yeah, this is a really great question that James brings up many times. So in proof of work, you can have these super light clients, and James is super well known for having built them for many protocols. And so it's actually good enough that you can do slow blockchain to slow blockchain. So you can actually do Bitcoin to Ethereum 1.0. But in the world of proof of stake, in the world of fast blockchains, you need to track additional contextual information. Basically how the validator set changed, how do you know if a new block header is valid? So ideally, you want to be able to track that with as little information as possible. And so the canonical smallest amount of information is just like a zero knowledge proof. What we do and what we fall back to in like the Tendermint world and some of the hot stuff designs. Hot stuff is kind of another consensus protocol that is vaguely like Tendermint. Is if the validator set hasn't changed very much between the last block you saw and the next block you saw, you don't need the intervening blocks. And though that mechanism, while not as theoretically perfect as a zero knowledge proof that like all the intervening blocks were correct and exist, is we think probably good enough. So that's what we mean by how light a light client.
But I guess the interesting question still is, like, you're still only verifying pretty much for light client the validity of the kind of block based on the whatever Sybil resistance is. You don't verify the validity of state transition.
Yeah, and for IBC you don't need to validate.
And so this is where the problem with like sharded systems comes in, is that because we have possibility that some shard go rogue, and obviously like at Near we have a way to contract it, but it takes time and may revert to chain. That actually requires.
Yeah, you have to wait longer for an IBC packet.
You need to wait longer, but also you need some kind of way of still recovering from that type of activity, right? And the normal way of recovering it is to providing a fraud proof, which actually tells you that that wasn't valid.
I think we can probably potentially get this kind of thing to work inside of IBC. Mm-hmm. Like we could have the ability, like there's nothing in IBC that says that like the sending chain can't just like declare a packet that it previously sent as invalid. It's possible. the semantics of that require, because what IBC does, and this is like one of the experiments that is IBC, that like if this works, will argue in favor of app chains, and if it fails, argues in favor of sharded chains, is that we can push a lot of the responsibility for validating whether or not onto like sort of end users, and that end user could be like an exchange that just monitors like the source chain of things. It could be, you know, the wallet that does it, or a wallet provider, or a block explorer. Like that, there are people out there who will like keep an eye on these source chains and be like, oh, something either terrible has happened there, or something that is part of the process, but like sort of a black swan event, like a state reversion has happened, and sort of make enough of the economy aware of it that gets priced in.
Yeah, I mean, that's actually like my main argument against like something like ABC, is that now you're kind of pushing the security on the user side, where as a user I need to be aware of that the asset I'm trading on Binance DAX is actually issued by a CryptoKitty chain, for example, which may or may not be valid at this point, right? So I need to be like aware and kind of know what's happening, what's the source of this, and ideally be like looking at, hey, is that chain actually still alive, right? Maybe like all validators quit and that chain stalled and this CryptoKitty doesn't actually worth anything.
Yeah, it's really an interesting open question about like how well markets price this kind of thing at maturity. And we may not know for like 10 years.
But like when you say price, right, that means you're mostly talking about assets that can be like priced by, let's just call it like some market forces, right? If you're talking about user data or some other information which, you know, has value to me but to nobody else, now you cannot use that anymore. Like you cannot use market pricing as a kind of argument for data validity in a way.
Yeah, let's think a little bit about that. What's like a good example of a use case though?
I mean, the example we like is like social graphs, right? It's like, let's say I have my social graph, which is encrypted, you know, and I, for example, want to use it in some other application on another chain, and like I need to prove that this is my social, like some connections about it, so I need a Merkle root of that or whatever, and I have a zero knowledge proof that, you know, I know those people. I mean, I'm just making this up right now. But like you actually need to send that Merkle root to the other chain for it to kind of validate it, and like some history of it. And if I do that, but the other chain disappeared, like that Merkle root has no value to anybody else in a way except me. And maybe a counterparty, right? Like maybe I'm actually trading, maybe I'm selling my data to Facebook for whatever reason. And you know, to Facebook it has value, to me it has value. Nobody else would like pay any money for it. Partially because I'm not going to give keys to my data to anybody else as well.
Yeah, so this is what I would describe as like sort of some variant on the data availability problem, which is in Cosmos. So in most sharded blockchains, and there's some not exactly sharded blockchains that also have these properties, in Cosmos blockchains, we don't assume that data is available across chains, which has one upside, which is it allows sort of private proprietary systems to interact with public blockchains using the same protocols that we use to do public blockchain to public blockchain interaction, which seems to be a useful factor, potentially is useful. But it has this downside, which is you don't know whether or not the source chain is going to exist, and if the source chain becomes unavailable to you, it's going to have some impact on your ability to use the wider ecosystem, and that might end up being really hard to reason about. And I fully accept that like might be a downside to a Cosmos-like system. It may not be a problem in practice. It may be that like you look at the validator set of a chain and you're like, okay, this is like pretty likely to be to remain available because, you know.
That's all the same people.
I mean, there's like 200-ish validators in the world right now. I think one of the biggest constraints on growing the validator set is proof of stake blockchains have to become a lot more valuable before we can afford to pay significantly more people to run validators. Like, you know, like Cosmos, as a practical matter, can't even pay 100 validators right now. enough money for them even to like break even.
Yeah, I mean that's definitely kind of a
It's a significant challenge in this space. So yeah, I think IBC, like, these are the challenges that we won't really start to understand until the system is live and has been out there for a while. So I'm really glad that like other system designs are also evolving in parallel. And I think short term, like a big use case is going to be like bootstrapping liquidity, bootstrapping initial applications on all of these different fast chain design variants. So we can quickly, so like it's not so, you know, you don't have as hard a problem of bootstrapping an entire economy as we try out new technology.
Yeah, I mean, like I agree that that's definitely like given Cosmos is already here, and you know with with Game of Zones launching, that's definitely interesting. I think like looking forward, right? The question is where the balance will lean toward. Like where would the newcomers, new developers in the ecosystem come in, and how do we like guide them from like, well, if you're building this kind of application, you should choose this type of platform. Let's assuming there is a platform that is fast chain, scalable, and actually has enough of this liquidity and partnerships already set up as well.
Yeah, I mean, I think you are definitely, so what I expect is that both will exist. I think larger organizations, large communities, pre-existing communities will almost always choose to build their own sovereign chain rather than jump on some existing chain just because they want the sort of full integration of the stack. We'll see. Well, you want to push back against that?
I mean, the question I have, and this is like a pricing question as well, right? Because like if you're launching, let's say I'm a community, I mean, like we were just talking, that there's like some communities from Reddit that actually spun off as their own like website and their own, like it's not a blockchain at all. They just literally need a way to monetize the community.
And they wanted sovereignty.
And they wanted sovereignty on features, but like they don't really care like where the financial system comes.
Sure.
I mean, they're not using blockchain right now, right?
You know what I'm saying? Yeah. They're just using databases. The blockchains are just databases.
Yeah. But the question there is mostly like how much they're willing to pay, right? Because you're saying Cosmos Hub right now is not breaking even. If we're talking about something even smaller that like has a smaller community, then it's even harder to break even to have validators to care. And then you have smaller set of validators, which are, by the way, very correlated with every other validator set. So at the end, you're kind of getting the same security as like from an individual
You
perspective.
only need, on the whole, like one high-value blockchain to sort of anchor a set of validators into existence. Mm-hmm. And then, I mean, this is mostly, like, this was our hypothesis, but I think it does describe the world as it is, which is mostly what has happened is, like, okay, so there's been enough, like, Cosmos is profitable enough to bootstrap, 20, 30, 40 validators into existence. Those validators can make money to sort of pay the bills and keep the lights on by running Cosmos validators. Hopefully with launching IBC, they'll make some more money, not just from atoms going up in price, but actually like transaction activity, securing other chains, like actually interesting crypto economics. And then they use that as kind of their base, and then they go out and secure all the, go out and talk to all the other chains and, find other things to secure and find incremental value. It's not like one of the things that's, I think, interesting about the proof of stake world is it's not clear that every chain fully pays for their own security. It may be that all of proof of stake collectively sort of subsidizes the security of all of proof of stake. That there's one stake security pool, and because reputation effects are so large that effectively you can be a much less secure chain, but let's say because Polychain Labs or Occlusion or somebody else who has a lot of reputational skin in the game decides to validate on you, we make Occlusion makes almost no money validating on Terra. We do it because it is an interesting project in the Cosmos ecosystem. We think we can probably upsell other services to the Terra ecosystem. There are a variety of reasons to do it, but like on an operational day-to-day basis, where we have lost money on the Terra ecosystem, but we still run Terra on our production ecosystem, and like the Terra ecosystem benefits from the security that of like the full occlusion system.
So you're saying if somebody comes in and tries to bribe you for Terra specifically?
Probably not going to do it. Though, like, there have been Oracle attacks on the Terra stability Oracle. I haven't done a lot of analysis on like how those happened though. So, but like for like validator infrastructure, they do run on occlusions production infrastructure.
I mean, Oracle's is a separate story because there's.
I think any validator can like contribute to the Oracle though. So it may have been some validators involved in the attack. We also had like the largest double signing slashing event on Cosmos so far on the Terra blockchain.
Yeah.
Like a $50,000 slashing event.
So this is a good point to sort of turn it over to the audience. I think actually the first question I'll ask, because I have moderator power, which is kind of changing gears. Like, I'm really curious about sort of looking inside of, I mean, I know a lot of the stuff that goes on inside of Near, but this is to both of you either way, which is looking inside of your organization. What are like some of the mess ups or things that you wish you would have done differently, or things that you were like oh shit moments that you learned a lot from that were like, formative for how you moved forward?
I guess the thing that has been honestly a real challenge for Cosmos is that transition from launching a system, like that launch moment to we're 6-ish months out from launch, and while we were working towards launching, we had like singular purpose. We knew how to prioritize resources. It was obvious like what needed to be done next. We agreed on a launch roadmap that we essentially followed in April 2018, and that took us all the way basically to March of 2019. We had a year of just this is the thing on the list, that's done. We'll do the next thing, that's done. I think it is really hard as a ecosystem, once you get past launch, to figure out what to prioritize, what's more important, what's less important. Should we be making Tendermint faster, higher throughput? Should we focus on more features that are appropriate should we do likelines? And honestly, at least we have IBC to get out the door. So that gives us some amount of focus. And pretty soon we'll have IBC out of the door, and then it'll become even less clear what is the obvious next solution. And maybe what happens, so part of our strategy has been to spin up, help spin up other teams that are beyond Tendermint, and that has worked okay. But yeah, it is a little bit of the next phase, the phase that comes as hard as launch is, the phase after launch also super hard.
Great. Got stuff to look forward to.
Yeah, that's something to look forward to and make a note for sure. I think on our side, I think the kind of hardest pivot of sort that we did was switching pretty much totally how we do sharding. That pretty much at some point we realized that the design that pretty much everybody else uses right now, and kind of was what Ethereum has been doing before, is very much affected by adaptive adversarial corruption. It's affected by data availability issues, and then also very hard to implement. And that was kind of we actually implemented it, or big part of it. And as we were trying to figure out what is all possible thing that can go wrong with this, we're well, just figuring out how to get it to actually production state would take so much time. And at the same time, we know all of these known issues with how to break it. So.
And as I mentioned, if it breaks, it's really not obvious how to put it back together.
Yeah, so that was let's just say we did somebody did break it, there was no clear way to reverse it. So that's where pretty much spend some time, and specifically Alex spent a lot of time thinking is there a better way to do sharding in general? And then we just kind of sat down by whiteboard and just cut down all those things, making it simpler and simpler and simpler until we actually made design very simple, such that A, it's easy to implement, B, it's easy to understand, and C, it solves all those problems. And that was like a pretty transformative moment and obviously pushed down a little bit from what we expected to launch. It also forced me to implement Tendermint with our runtime, just so we have something running for some of the developers we have.
Well, I mean, I would say that, you know, for instance, with IBC, what we decided, so like, you know, for many of the pieces of the Cosmos stack have been rewritten in once or twice or 3 times. And a lot of the reason why we think that was necessary is we didn't do a lot of design work up front. So one of the things that we really focused on with IBC is do like literally 4 months of design work in like an open community process where like it was mostly Tendermint Interchain Foundation and Agoric folks, but there were other contributors as well who would come along and like do a design process with all of us. And hopefully the plan is that allows us to deliver IBC in a faster way now that we've shifted into development. So far, going pretty well. And we'll find out, you know, we still have, you know, we had this demo, we have security audits, we have a somewhat unclear idea of what launching looks like. So there's still a lot of work to be done.
Cool. All right, yeah, I want to turn it over. So does anyone have a question? I can pass you the magical cube.
I feel it was awesome listening to you guys, but I feel like the very, very first question was never answered. Like, if I'm a developer today, why do I use Cosmos? Why do I use Near? Can Near work on Cosmos? What am I supposed to develop where? Which chain do I choose?
So if you're a big company, then you can go with Cosmos.
I mean, smallish startups have had some success. I mean, but it's certainly not, there is admittedly no real clear path for like a solo or 2-person, 3-person team to end-to-end launch a Cosmos, you know, chain.
And I would say, like, if you're a smaller startup, it really depends on what your goals are. Because if you really want to deliver a product, if you really want to get in front of the users, you should go and build on something that provides you all the infrastructure, right? The same with, like, if you're building a startup and really what you're trying to do is get your product in front of the users, you should go on AWS or on Google Cloud. If you're trying to build, you know, a robotics farm or something, or if you're trying to build like
some cool stuff that we've seen like on Cosmos is something called Akash Network, which is by one of the founders of Firebase, or actually I think the founder of Firebase and CEO before he sold it to Google of Firebase. He built this whole control plane for like arbitrary Kubernetes workers on top of the Cosmos SDK. It's insanely complicated. Or if you are a big company, but you only have a small number of developers, but you have like a very clear product vision like Terra did. Like Terra, I think probably had like 3 or 4 developers. Even though they're like, you know, they've raised lots of money, they're part of like a large corporate entity, like network in Korea. It allowed them to like just like get a fully integrated system out the door like really fast because, you know, there is a ledger app and validator infrastructure and HSM integration and a web wallet that you can fork and all of that stuff. Like all those pieces actually are there. So it does accelerate your time to market. Where people are obviously frustrated in the Cosmos ecosystem is that's like, I have some simple idea that I want to try. I'm going to try some financial like primitive, some variant on staking, some like I want to just change things up in maybe a small way or experiment with something new. Like Cosmos does not currently offer any real path to this. Now, you know, probably potentially months or years down the road, we intend to have things like you know, cross-chain validation where like you can just pay some Cosmos Hub validators to validate your chain sort of in protocol. And so like a single developer could sort of negotiate all of that in protocol and have a chain come into existence. So I imagine things like that become possible in 2 or 3 years. But you know, Near might just be like completely awesome by then. And maybe people aren't as excited about that. So there's two sides to this.
Does that answer your question? Yeah. All right, cool. Anyone else got questions in the back?
Completely awesome now.
I mean, Alex has to has a bunch of code to write, so.
I just got a quick question, primarily on IBC. So let's just stick with like an ERC20 token. If I'm trying to send it to like 2 different blockchains integrated with IBC, let's say Binance Dex and somewhere else, do I need to also build the original smart contract on both of those other chains in order to mint it on those new chains?
No. So basically the way, so this is called ICS20, for whatever reason. It is the token transfer standard. And basically, so IBC is designed to be between heterogeneous systems. So like, you might have a minting contract that is in, a minting and freezing contract that is on Solidity on one chain and runs on the EVM. And you might have Go code in the Cosmos SDK on the other chain that implements the comparable business logic. But if the ICS20 standard is implemented on both sides, there will be a freezing and minting contract on one side, and there will be some module that implements freezing and minting on the other side. So you should be able to send your token, whichever chain you're on, to that implementation and immediately get it in the form that it is in the other implication. And like things that we had to do in order to like preserve like that vision of compatibility are like, for instance, Cosmos SDK integers are 256 bits, like Ethereum integers, which everyone hates. But like they were like, there's so much fighting about this, but because like we really don't need anything more than 64-bit integers, but we made them 256 bits to make sure that we could support, ERC20 denominations, which are 128-bit. Does that make sense?
Yeah, I guess, so either way, like if you were trying to send a maker token and a DAI from Ethereum to Cosmos, wouldn't you need 2 separate contracts on Cosmos to track ownership of the Cosmos maker token and the Cosmos DAI token?
No, so like the ICS20 implementation on, let's say, the Cosmos Hub knows how to handle tokens coming from arbitrary blockchains. So it basically says, you don't have to implement a new contract. It just says, an ICS20 message has come in, I do this, now there's a maker token that originated on Ethereum on my chain. Same thing with DAI. So typically, in the ICS20 ecosystem, like all of the complex business logic about when do you issue and stuff like that will reside on the source chain. So you'll have arbitrary things, but then you just implement this uniform ICS20 packet, and then any other chain that like understands ICS20 can just like know that the token is frozen on the source chain and instantiate a movable token on the destination chain.
So you can only move the kind of, let's just say, NFT or like a fungible token.
So that's ICS20, and then there's another ICS that I don't remember for NFTs. And no, I forget what they picked. And then, but like we also have like, so then you have, and like we imagine there will be many of these other application layer protocols. Like another one that's being worked on right now is cross-chain accounts. So accounts that sit between blockchains. So like you have like an account on one blockchain that is essentially controlled by the validator set of another blockchain. That's an example of like not token transfer use case. Cross-chain staking, all that stuff. And then you have what Agoric has been working on, which is sort of a generic code and message in JavaScript transfer system that also will live on top of IBC. So we have all of those, and I'm kind of hoping, over the next months to see the developer community come up with lots of new application layer protocols.
I mean, we just have it easy. We just have it all in one chain in the same protocol. So
sure,
you can call anything, get anything, and it all works. So.
Yeah, so I mean, you just have like a function call interface between that like is exposed either both on the same chain and on multiple chains. Yeah, I have so many questions.
Have you considered the idea of incubator?
Like IBC incubator?
Or Cosmos apps incubator?
So I guess the big thing that like I really feel about like, so if such a thing existed, I would want it to be a dApp, is basically what I would say. I think that one of the biggest, like, I'm hugely critical of like ecosystem funds and like incubators from the project team. Like all of your judgment about like what is good and what is bad is totally corrupted. Your ability to deploy capital is completely like misaligned with incentives. You're bad at judging things. So, and it only gets harder. So like, I would say that, we're 6 months into having Cosmos be live, and it's kind of been completely obvious like what we should put resources into. And I think every month that goes by and more of the like sort of general investing community starts to like believe in our ideas, it becomes harder and harder to like figure out like what's under-resourced, what's good, what's bad. So if there isn't some sort of like novel investing like decision-making structure on top of this, I have never really believed in like that kind of a mechanism.
Yeah, I mean, like from our perspective, the way we think is like this space right now is missing really like successful companies, and like
Hell yeah.
and like part of it is like when we go and talk with our friends outside of crypto and like say, hey.
Oh, you have friends outside of crypto?
Yeah. And
You're a lucky man.
well,
I don't have any friends outside of crypto.
and we're trying to convince them to quit their job and start building in crypto, so we have more friends in crypto.
See, that's what happened to me.
Exactly.
I convinced all my friends who were not in
didn't-
crypto to be in crypto.
We didn't exhaust that pool yet. The feedback there is that like, hey, we've been building and been successful in doing Web 2. Like so, Sasha has a friend who built Patreon, for example, and like they have there's huge amount of tools you can build really quickly. Yeah. There's a huge amount of users you can onboard, and there's business models you can use. And here in blockchain, like we're kind of lacking, even if we have ideas how to solve some of these problems, we still lack in examples that people can like, oh yes, and like Firebase actually is like interesting example where when they launched, they had like few example apps, which people like, oh, like I don't care about the apps that they have, but like it's a good example of the use case that I want to use in my own app, right? And that's how I actually started using Firebase myself. I was like, oh, like I don't care what that is, but like it was interesting experience that I tried, and like okay, now I'm gonna go build something on myself.
So I feel really torn right now. It's like, so like it was obvious that until we had like scalable, fast proof of stake blockchains, it was going to be really hard to build anything that anyone would want to build with. Like, so it was like, it basically last like 3 years of my life to make sure those came into existence. And now they exist. So now what's the question? Is the, and like we struggle with this internally inside Cosmos, and we argue about this like a lot. And this is, part of the having a live system, but like trying to pick direction. Which is, there's one strategy, which is go all in on like base layer tooling, build a mobile SDK, build a JavaScript SDK, like get IDE integration, like just make all of those tools come into existence. But all of that still assumes that someone else is going to come along and actually build the application. The alternative strategy is to go all in and building an end-to-end application yourself, and maybe hive off any of the tools that you had to build along the way, but like focus on like one good solid use case. As an organization, as a company, certainly both approaches sort of exist inside Cosmos. We don't know which one to pick, but I think almost every project is going to face a similar dilemma.
I think, the kind of incubator idea, right, is kind of doing both. And I agree that it's totally biased, and like when you need to pretty much when you're giving money to somebody, that's where the judgment is totally off for sure. So this is where like you can, but there's so much other help you can provide a project, being in this ecosystem, right, with the knowledge.
You
everything else.
give them access to developers. You can prioritize their tech support requests. You can build libraries that they need based on like what they do. And we've done some of that. And like, there's an application we'll show up at the DeFi hackathon called MicroTick that is like very much like, there's no formal incubator, but we like definitely incubated that application using a combination of resources from externally, the originators of the project, and our internal resources.
Yeah, we've been doing that for projects building on us.
I think I've been seeing it, and I'm excited about it.
Yeah, and a big part of it actually helps us a lot to improve our own like developer experience and user experience, because it kind of is immediate feedback loop from their users and their developers too.
Yeah, I mean, if you don't have a close relationship with your developers and you're just building tooling, it is easy to sort of wander off into the weeds. Well, I mean, I think that's what Consensus was able to fill. None of their applications were really that successful, but there was some benefit to sort of co-locating application and tooling development. Like the tools are the parts that have succeeded and actually have adoption. Basically, none of the applications succeeded, but maybe there was some benefit to having a feedback loop.
So if I want to go about implementing IBC, let's say, for example, on Near, where do I start?
There's a Rust implementation of IBC that is being, like some of the pieces of IBC that's under the Interchain GitHub, which would probably be pretty helpful for building one that targets Near. You can probably build all of the pieces of IBC targeting just the Near VM. You don't have to make any base layer changes. And then the other part, which is the hard part, is how to build a light client for their consensus protocol, which may require some more help.
Yeah, we're working on that because we're actually building a bridge to Ethereum, and we already fully figured out how to verify Ethereum headers in like very nice, cheap way.
Nice.
And now we trying to figure that out the other way. We're verifying like our headers pretty much on Ethereum, which is way harder.
Yeah, I think there's lots of people on the sort of Cosmos research team that would love to talk to you about it. We're frankly very interested in helping build light clients for other protocols. We've really not seen any other research efforts that are, we just had a presentation today from the ChainSafe team on ETH2 light clients, which went well, but it was also very confusing. And yeah.
Did it involve hard forking ETH1?
I would say that, light clients were a thing that we thought were easy, and then over time realized was hard. And then we tried to do it, and we realized they were hard. And then we spent a lot of time writing specs, and now we have implementations of those specs, and hopefully that's good enough. I do think the approach that the Cello team has been following is also pretty rigorous. But we desperately need, light clients are the basic building block of interoperability, so if we've got to figure them out for a lot of different protocols.
We got a question over here as well.
You guys have been talking a lot about slow and fast blockchains. What makes you feel like the new generation of blockchains is fast enough, or significantly fast enough that it's going to be different than what you're calling slow?
I mean, from our perspective, we're building a sharded blockchain, but more specifically, we're building dynamically sharded blockchain, which means that over time, as usage grows, we actually add more capacity to the network and resize it, add more shards, which really means that, obviously, I mean, there's theoretical limit on networking, etc., and it is quadratic sharding at the end, so a lot of asterisks, but it is actually expands with the demand, so it doesn't have this idea of slowing down, or it doesn't have this idea that at some capacity now you kind of either bidding or waiting for a transaction to settle. And then the other side of it is proof of stakes in general are faster because you know who the next validators are. and you don't actually need to wait for block propagation. You can just send them directly. You can pipeline a lot of things, kind of align everything such that every single thing happening as fast as possible. And like, for example, like we were just talking about the finality gadgets, like the Tendermint finalizes every block, but that requires 2 rounds of communication. You can actually pipeline even that and have like 2 blocks in advance already produced when you're finalizing 2 blocks before.
Crazy Chinese people actually implemented this and then ran out of money, but their GitHub is still there.
Oh yeah, so Alex implemented that yesterday, but yeah.
I mean, and that's how Libra works. Also implemented pipelined consensus. I would say there's a couple of things in my mind that distinguish fast and slow. And I mostly think that like once you are so I'll describe what sort of gets you into the category I call fast, and then I will argue that once you're in the fast category, being faster probably doesn't really matter that much at infinity. There's certain applications and certain use cases where it does, and there will definitely be specialization. You know, there are going to be use cases where like the insane throughput of like something like Solana is appealing. There are going to be applications where, you know, a slower Tendermint style chain is kind of is appropriate. But okay, so one of the big things that differentiates slow and fast blockchains there's like 2 characteristics in my mind. One is synchronously safe versus asynchronously safe consensus. So Bitcoin is slow because of its consensus, Nakamoto consensus, is only safe if you can assume that all of the parties that care about your blockchain will be able to receive a block within a certain amount of time. So, and that time, Bitcoin has parameterized as 10 minutes. Ethereum has parameterized it as, I don't know, some number of seconds? 12 seconds, yeah. Ethereum's parameters are clearly far more aggressive and probably represent the upper limit of what you can do.
Well, they're also using uncles as a way to kind of circumvent some of the game theory that comes in.
Yeah. But like that doesn't get you around like pure delay.
Yeah.
So whereas a protocol like Tendermint, the validator set can finalize blocks as fast as they want, as fast as they can. And you are not going to end up on a fork of the network or like seeing inconsistent state because you're receiving blocks slower than that. And at some point we'll have state sync enabled. Binance already did it, but under weaker security assumptions. And you won't even have to have the burden if you're not a validator node of seeing all the blocks. And you'll have this basically the same security guarantees. From that, like the sort of optimal, you know, given infinite time and infinite money, what Tendermint would actually look like is if you were running a full node, you wouldn't actually sync all of the blocks. You'd only sync state from blocks that you care about. You'd ignore the transaction data. And like the only things that would ever see all of the block data are the validators. And that can be very fast. And so that's fast. And like you might have caught on to a little bit in like my explanation is one of the consequences of that is state becomes a lot cheaper. State for Ethereum, state for Bitcoin is really expensive because that state has to be globally propagated to everyone who cares across a global network. And because state is expensive, things like white clients for other chains, highly stateful applications like gaming, et cetera, become, whereas there's a Tendermint-based chain, Loom, that at least over the summer has like a 200 gigabyte state and is like mostly chugging along just fine. Like hopefully we made some improvements to our Merkle trees that like made those less IO intensive. But in general, like you can have these like very stateful, very large blockchains when you have asynchronous consensus, asynchronously safe consensus that you can't have in the slow Nakamoto regime. So that's why I think the emergence of these fast blockchains like fundamentally transform like what the use cases are for blockchains, but is going to be at least 10 years, if not longer, before we have confidence in these systems as base layer money.
Cool. We have time for one last question from the audience. Were you guys raising your hands or just scratching? No? Okay. Anyone?
I think there was a question. You're good.
No? Okay.
I've
oh,
intimidated
yeah, sure.
everyone.
So what's your current working approach
That's fine.
for how you're going to build a light client on Solidity on the UVM for Near?
For Near. So the idea right now, so we do have actually a light client. It's just not that light. That's the main issue. So we actually have state sync. It works. Like if you run a node right now, you will not need to validate every single block. And in the sharded system in the first place, you cannot validate every single block. That's a kind of whole assumption. So we do have light client. We just validate headers. The way we elect and select validators is somewhat complicated because we're working around a lot of kind of proof of stake inherent problems that capital efficiency of proof of stake as price fluctuates is very unclear. So you actually need to adjust the price per validator seat. So like Ethereum has 32 Ether, which is like an arbitrary number taken from, I'm assuming Sky, but I hope there's some math.
Laptop.
Yeah, I think it may be 42 minus 10. That's probably what happened. But like we actually have adjustable price, adjustable kind of stake size that you need to be a validator, and that requires actually doing a pretty much like a sort and shuffle, right? And that is like in Solidity expensive because you actually need to transport that information.
Can't you just have the last validator set sign the next validator set and do that?
You know how many times I have argued that this is the worst idea ever?
Really?
Because if I'm a validator now and somebody kicked me out because I don't have the stake anymore, why in the hell I would sign it ever?
Well,
instead I should sign me myself, right? And like if you have a majority,
but that's just holding the chain.
It is holding. I mean, like I agree that this is an option. If there is a better option, I would prefer using that. I think like relying on this assumption that you have like two surds carrying over from epoch to epoch, because that's kind of what you're saying. If there's less than two surds, or
No, that's not what I'm saying. I mean,
if there's more than a half that got kicked out, that half should collude and sign themselves back into the next block and control the light.
yeah, but that only tricks light clients.
Yes.
And it's slashable on the main chain because they're still bonded.
Yes. So yeah. So if you're adding like slashing conditions from other chains, that's true.
Yeah. No. It's not slashing conditions from other chains. Like the signet. Well, I mean, this is really getting into the weeds.
Yeah.
Like,
Okay. But I got your point. Yeah. So there may be some.
We have a great write-up on all of this on our light client research blog.
The one important thing that we want to add is such a thing called skip block. And this is the idea that you're actually building a skip list of blocks, so you don't need to verify. So we're producing right now 1 block a second, and this is a lot of blocks. So you actually like want to skip a bunch of blocks when you like traversing a chain. So if you just produce a skip blocks within an epoch, that's fine because it's the same validator set. And you kind of can just skip epochs.
We call this the skipping validator.
Yeah. So I'm sure there's like some more ideas how to get it to the state where it actually works. And the main problem again is like the prices of Ethereum gas on signature verification and things like that. And our desire to have more validators as like network expands.
We've mostly given up on the idea of like that's why we have pegs.
Yes, I know. That's why I was asking like how are you gonna do it for other chains because yeah.
Well, I think for like fast blockchains, it should be fine. ETH 1.0 is this weird, like it's not a fast blockchain, but has some like interesting programmability properties. So there don't seem to be like options for doing like low trust bridges, but it's tough. Look how complicated DTC is.
Yeah. So yeah, TBDCs, but yeah. Stay tuned for a video we actually have with Matt Long and James about TBDC on Near, I guess, on our YouTube or on their YouTube.
So yeah, I want to wrap up on something that like a lot of these conversations go super deep in the weeds. And so I want to pull back because these conversations happen in like rooms, but they don't often happen on the stage, which is like, and try to keep it super short because we're going to go over time by like 2 minutes. So what is your like 100-year vision? Like the sci-fi future where blockchain wins. Like you have to think about that at some time, like maybe when you're going to bed or in the shower or whatever.
Decentralized spaceship market.
There you go.
Like global mass participation in political systems.
That's your end goal.
That's the end goal. Yeah. Like I don't think you can have global money until you have global participation.
Cool. So it's like one world order. Yeah. Are you in the Illuminati?
Yes.
All right. You guys heard it here. Cool. Illia, do you want to say anything to that, or are you good?
I mean, I think like what's really interesting is as we go, especially if we go interplanetary, how's governance for sure, economics, how these things will actually be evolving.
You definitely need IBC if you go.
Because you're going to Cosmos?
Well, you just can't be synchronous between, the Earth shards and the Mars shards.
You just run, I mean, it's all asynchronous, man. It's,
Cool. All right. Thanks everyone for coming. That's a wrap. I do want to make one quick announcement, which is that Near's Stake Wars is starting on Monday. So we're actually kicking it off. That's our incentivized testnet, kind of like Cosmos is Game of Stakes, right? Game of Stakes. So yeah, we learned a lot from them and talking to Zaki, of course. So yeah, if you guys want to participate, test out running a node. Even if you don't plan on being a validator, it's going to help us a great deal. And it's incentivized, which means at the end you can get tokens on mainnet. So check it out. It's nearprotocol.com/stakewars or near.ai/stakewars. So thanks very much. You guys have been an awesome audience. You want to give them a round of applause? It's been awesome. Yeah.